The question is, each one of these things, we're going to figure out whether they're aromatic or not. So is this aromatic molecule or not? I mean, by the look, it doesn't look like aromatic, right? But now you know this carbon is a carbocation, so that means it has a P orbital there. And the oxygen, typically the oxygen is sp3 hybridized, having a 2 lone pair sitting on the sp3 orbital. But it can be sp2 hybridized too. So what we can think about is that these lone pairs, if they comes in, make the double bonds, they push it out, they draw the resonance structures, but that's sort of like, it looks like we have aromaticity. So this thing is actually aromatic. I mean, obviously, oxygen, the one that carry the positive charge, but that cation is a stable because of aromaticity that it has. What about that one? So what you can do, so you do the same thing, the oxygen is lone pairs, you can push it in, making a double bond here, that's going to push the out. So it looks like an aromatic molecule, just like we have seen here. I mean, oxygen is going to be positively charged, but it could be positively aromatic. What about this one? It looks like everything becomes aromatic as soon as you push the electron. But there are some things that you still have to remember. Well, like we did, we can push the electron here, we can push the electron there, just like this. Then we can make a benzene type of structure down here. So it looks like aromatic, but you're forgetting something. This oxygen has only 6 electrons in the valence. So it's not even having an octet. So that is a very, very bad structure. It's not about having the benzene down there. The whole thing has to be stable. So this electron move is wrong. So this is not aromatic. What about the ones that carry nitrogen? Can they be complicated? Well, first of all, will this molecule aromatic? Well, let's think about it. Nitrogen is a lone pair. The lone pair nitrogen comes in, makes a double bond. This comes in, makes a double bond. This comes out, and that is actually looks like an aromatic. So what about the one down there? I mean, suddenly we got a strange element is there. It's the boron. Nitrogen has a lone pair, right? So by the same thing, we push the lone pair comes in, make a double bonds. That double bond comes in, make a double bond with the boron. That makes a boron negatively charged. But boron in the group 3, in neutral state, it has only 6 electrons. So having negatively charged, now finally boron has 8 electrons, octets are filled. So boron can accommodate those 2 electrons without a problem. So this molecule becomes aromatic. Once again, it looks like everything becomes aromatic as soon as you push electrons in. So this is aromatic molecule. We could potentially do the same thing. We can push the electrons comes in, double bond, that comes out, makes double bonds. It looks like the same thing, right? But if you think that way, you're forgetting things that oxygen already have a 2 lone pairs, then you are making it having another one. You're giving 10 electrons to the oxygen. So that is really, really bad. Just like a 5 on the quarter, it doesn't happen. So this is not aromatic. But be careful, because sometimes you just see how the problem gets solved, you just memorize how to do it, you just apply that way to anything, expecting to get the right answer, and that normally is bad. Because we normally use the failing ones to ask the question. So be careful memorizing. So anyway, this is not aromatic because of oxygens already have 8 electrons, and then you're giving 2 by having these resonance structures, make this oxygen overpopulated octet. So that's the one that makes it very unstable. So this is not happening. Will this molecule aromatic? Now the ring size becomes a 7 ring. Well, thing is, these pi electrons better go to oxygen, then oxygen gets negatively charged, this pick of carbocation. But that carbocation, the second member ring, is actually a good thing. Remember that? That is a tropylium ion, 6 electron pi system, planar. So that becomes aromatic. So this one, even though it doesn't look like aromatic, but it is aromatic. What about that one? Same thing, I just changed the 5 member ring. If you do that, same way, push the electron pair goes out, you make the carbocation right there. This is a 5 member ring with a cation. How many electrons in the pi system? There's 4 electrons for the 2 double bonds. Just down from there. So this is not aromatic. I mean, you may think that this becomes anti-aromatic, but the molecules are not stupid enough to go there. They're not even doing that. They're not even push the electron goes away. But they stay just non-aromatic.